Welcome everyone to another episode of Faith Unaltered. I'm just one of the three awesome co-hosts that you have with you today. With me, Dane Von Ace, Dale Glover, and our special guest, Dr. Robert Sungenis. We're going to be talking about geocentrism. And so with that being said, guys, Dane, how you doing, brother?
I'm doing great. I am super excited about this conversation that we're going to have. I've had Dr. Sungenis on my radar for a while now, and listening to some of his lectures and watched his documentary, The Principle. And I find this topic really interesting, and I find a lot of the arguments and data that Dr. Sungenis is bringing to the table to be very compelling. So I'm excited. I told Dr. Sungenis backstage I'm on the fence with this topic, and I want him to bring me all the way over to his side because it's an exciting concept. And anyway, I'm really looking forward to this and just grateful to have the opportunity.
Look,
So
Dane,
I'm
I
good.
don't think it's going to take much for you, bro, because you got me very interested in this conversation. And
Yeah.
so we were talking about it, and I said, I didn't even know this was a thing, bro. Not a clue. I've seen Dr. Sungenis debate James White, but other than that, I was like, what's geocentrism? So I said, all right, I'll try to reach out. And we got in contact with Dr. Sungenis. And so thank you for joining us. It's a pleasure to meet you, and I'm excited to have this conversation as well. Before I introduce you, though, Dr. Sungenis, Dale, how are you doing, brother?
Hey Tyler, how's it going? I'm doing well. This is today's going to be a busy day for me. This is my second of three podcasts today, so quite busy. But yeah, I'm looking forward to this too. I know next to nothing about the issue. I've never researched this in depth, so it's going to be. I'm interested to see what has Robert got. I am not on the fence. I lean skeptical, but like I said, I wouldn't be able to debate Robert at this point. So yeah, I'm interested to see what he's got.
Right on, right on. Well, I appreciate you guys joining me today with this interview. So, Dr. Sungenis, welcome. It is a pleasure to have you, sir. How are you doing? Oh, let me.
Now that I'm on the show, so I'm always interested and amazed at the followers of geocentrism. By the way, it's not geocentrism; it's geocentrism. Just to make sure we're on the same wavelength there.
Awesome, thank you.
Some people say geocentricity. That's, I don't use that myself, but everybody knows what geocentrism is. So at any rate, I am just very happy to be here and help explain this whole issue. And you know what I find is that I can't make a blanket statement, but the younger people that are coming up the road, who, when I first started this were either babies or in their toddler stages, and now they're in their 20s and 30s, and they're the ones that are really grasping onto this and saying, oh my gosh, we have a whole new way of looking at the world. And they find out, well, it's not new, it's actually old, and we're just bringing it up again, because the truth can never lay down and be still. It's always going to try to rise to the top, Right. So I'm happy to be one of the facilitators of that. And that's all I consider myself to be, is a messenger boy. And so that's why I'm here, to give a message.
Right on. We're looking forward to it. And Dane, to get this interview kicked off, brother, this was your idea. So I'm going to go ahead and hand it over to you, man.
Well, right on. So I think we'll just jump right in because there's so much to talk about that, there's no sense in not just diving in head first. So, I think most Christians, I shouldn't say most, all Christians are dedicated to the belief that God created the universe. And I think that kind of modern cosmology, the Carl Sagan idea that we're just a random speck in a dusty corner of the Milky Way, which is a random galaxy in the middle of nowhere of the universe. We have kind of adopted that and said, yeah, but God still made the place, even if we're in sort of a random spot within it. But what I love about geocentrism is that it really reinforces the fact that we hold a special place, that God put us right in the middle, and that means we're unique, and that it kind of gives dignity to the planet that we're on. And so I'm really excited to dive into this. And I wanted to just first ask a few questions about, how you got into this. So what got you first interested in this topic? It doesn't seem like something that, just falls out of the sky and hits you. Like what was your door that led you into the geocentric studies?
It's a funny story, actually, because I had no intention of going in this direction, believe it or not. And now it's been 20 years down the road. One Sunday afternoon, I had nothing else to do for some reason. And I said, let me go on the internet and see what's going on there. This was back in 2003? Yeah, a long time ago. So I'm looking at, and I come across this guy because I was interested in science and they had some science issues up there. And I came across this guy who was saying that the Earth was in the center of the universe and doesn't move. And when he said move, he meant either revolving or rotating on an axis. And I said, what? They still believe this kind of stuff? I mean, but he had a PhD in astronomy, and that made me listen. Because there's a lot of wackos on, the internet who think they know what they're talking about. But hey, if you got a degree in the very subject you're dealing with, and you've been recognized as somebody who knows what he's talking about, I'll give you a listen. And so he's talking about that. So the next thing I had to decide was, it was a nice day out. Well, I was going to go out and play basketball with my guys, the neighbors, or I was going to press the next keystroke and get into his website. And I took that latter move. I pressed that keystroke, and that was it. It was over after that. So,
God's providence with one push of the button led you down this path.
Yeah. So I never did play basketball, but I spent the next 2 hours reading his website. And I was a physics major in college at George Washington University. So I was there for a couple of years as a physics major. Then I transferred over to theology. But I learned a lot of physics at that time, and I could tell whether the guy knew what he was talking about or not. So when I read his stuff, I go, that's interesting. I never looked at it that way, but that's true, and I had to admit that a lot of stuff he was saying just sort of fit together. And then it was just a matter of keep reading, keep studying, and that's what I did. And lo and behold, I'm a geocentrist today because of it.
That's awesome.
Yeah,
That's cool.
Awesome. Dale, you want to take the next question?
Yeah. So I obviously look taking this, I guess, non-standard position. You're going to face a lot of backlash from the scientific establishment. And
what? No.
Yeah.
Never happens.
Don't worry. I face it myself because I'm from Shroud of Turin, so I'm known as a kook as well. But obviously, facing this backlash, why do you think there is this almost an emotional reaction to even just questioning something like the Copernican principle? And why do you think this is such an important topic that for you'll face this backlash and say, hey, this is a truth worth dying for, so to speak?
Yeah, there's a lot of ways to answer that question. But the one I think is the most obvious is if you've been taught this since you were a child, books you read, nursery rhymes or whatever it is, you grew up with this and you believe it's true because that's what was told to you. And you don't have any critical mechanisms working at that time to say, is that really true? The Earth goes around the sun. You just read it and you accept it. Okay. So that's what you're dealing with. You're dealing with a lot of ingrained knowledge from the time you're a baby to kindergarten, to grade school, to high school, to college, postdoc, whatever it is. You're all told the same thing and nobody really questions it. You see. So because it sounds so good, that the Earth is smaller than the sun's bigger. So everybody thinks the Earth has to go around the sun. It can't be the other way around. That all makes sense to them. And that's as far as they go. They don't go beyond that. And that's where we are. So I think that's what we're up against. But as science has shown in its history, it changes its major paradigms about once every 50 to 100 years. And that's because they find out that what they knew before, they don't know so well now because they found out all this other stuff that the telescopes and the microscopes and the oscilloscopes have brought to them, that it makes them look at it in a completely different way. You see, that shift has happened a couple of times. And we would have to say that it probably started around the time of Galileo and Newton, those guys back then in the 1600s, and modern science has progressed since then. And it's even getting faster in its changes because the data is coming in faster now, and it's being analyzed faster. They say in 15 years, we're going to throw away a lot of what we already know today because of what we'll find out in 15 years. That's how fast it's moving, you see. So that's on our side, okay? And that's where we go grab our information and we say, hey, did you take a look at this? And the principle was one of those things that we brought to the fore that had just developed in the last 20 years or so, okay? So that information wasn't available before. But now it is, and now we can integrate it with all the physics that we have come to look in a different way from the time of Newton. And everybody looked at the world in one way. It was Newton's way, Isaac Newton. And then that 200 years later, that all shifted away from Newton to Albert Einstein, okay? Because they see the world in two different ways. And we side with the way that Einstein sees it, although he didn't know he was going there. That's the funny part about it all. He had no idea where he was going to end up. His first phase of knowledge was to stop these geocentrists from taking advantage of the new data and saying that the Earth is in the center of the universe. That's what special relativity is all about, okay? Yep. And that persisted for 10 years, and then he found out that he can't say that. And he had to develop a whole new theory called general relativity, and that brought us right back to, believe it or not, the Earth in the center of the universe, okay? Most people don't know this. I talked to a physics professor from George Mason University about 4 weeks ago. He picked up my book, Galileo Was Wrong, and he's reading it. And he couldn't believe that Albert Einstein's field equations actually took us back to a geocentric universe. He had never heard that before, never studied. This guy with a PhD in physics.
Wow.
And Dr. Sungenis, not to interrupt you, but isn't it true? Isn't it true that Einstein, in his book Evolution of Physics, he said, "My math works the same whether we go around the sun or the sun goes around us"?
Yeah, he did say that. And the math has to work. It's not just an idea that the general physicist has to have. He has to work it out mathematically so that whatever his field equations will allow a heliocentric universe, those same equations have to be reciprocalized, let's say, and make a geocentric universe, because that's what relativity is.
Right.
Relativity demands that. So they had some guys figuring out what those equations were. Hans Thirring, Joseph Lenz. There's been a whole slew of guys. Max Born did it and recognized it. And so that's the new information we have, you see, that the reciprocal is just as valid as the old model, the heliocentric model. And one thing I've learned recently was about Father Lemaitre. You know, you've heard the Belgian priest who they say invented the Big Bang. Okay. What I found out was that the real truth is that he was the one guy that took Einstein's field equations and said, hey, you can go this way with the field equations, and you can say we live in a homogeneous and isotropic universe, and that's the Big Bang universe, okay? Or you can take those field, and this is Lemaitre saying this now, okay? This brilliant mathematician, priest from Belgium. Or you can take those field equations and you can go the other way to say we have an inhomogeneous isotropic universe, and that's the geocentric universe. So but nobody knows that about Father Lemaitre. All they say, he's the inventor of the Big Bang theory, you know? And so it's a matter of choice with the science we have today, which one you want to believe in. And which one do you think they're going to choose? They're going to.
I know which one they choose. Yeah.
Yeah. Is anybody out there choosing geocentrism? No, except this idiot right here you're talking to, who's willing to risk his reputation for a truth that he believes goes real deep into mankind. like you were saying before, Dane, if we're in the center, that means we're special.
Yes.
And see, these guys don't want to be special. Why? Well, it's because, look, they know what kind of lives they lead. And here comes this guy telling them, okay, maybe he's not telling us to believe in God directly, but he's telling us indirectly.
Mm-hmm.
He's saying, yeah, there is a God out there much bigger and better than you are. And guess what? He's going to judge you for your life. And that's what we're saying to them when we say the earth is in the center of the universe, because they know it can't happen by chance. Somebody had to put it there. And that somebody has to be somebody really intelligent to put it there. So we bring them right on the doorstep of meeting God face to face, and they just can't stand that. And so none of them will choose geocentrism, and they'll just give it a wink and a nod to it and say, yeah, it's possible, but that's not the reality.
Can I just push back? Just a pushback on.
Go for it, Dale.
Okay, so one thing I'm kind of curious, because believe it or not, I think it's almost could be argued it's the opposite. If we're the center of the universe, like physically, that means there's nothing really that special, right? Because things would, of course, be centered around the main point of the universe and that. But if we are in a random place, then that's where you get an argument for intelligent design and the fine tuning of the universe, because there's no reason we should be in a special place where everything is designed to, support human intelligent life, as like Hugh Ross or William Lane Craig and those guys would argue. So couldn't it be argued that it's the opposite? If we are in a random place, that helps the intelligent design argument. Whereas if we're in the center, things just naturally gravitate towards the center. That we're not as special. What do you think of that?
I think, to be very honest with you, I think it's a little convoluted. Okay, I say that politely, but the intelligent design thing, if they went to the next step and moved away and advanced the idea that the earth is here and it's everything around it that gives life to it is intelligently designed, okay, and then they moved to the next step and they said, well, what would be the best place to put the earth to show that it was intelligently designed? And this gets into which universe actually works better. The one that has the earth out there in the remote recesses of space, or the one that puts the earth in the center. And the one that puts the earth in the center actually works better and more consistently, non-randomly. And you can see that the intelligent design is even exponentially raised because the earth is in the center. Now, let me give you just one example. The earth in the heliocentric Copernican view spins on an axis. Okay. Every day, 23 hours, 56 minutes, and 4.09 seconds, it completes its rotation. Okay. It actually rotates faster than the sun moves. So the earth and the sun don't meet up, and that's what gives us the year. But it's 23 hours, 56 minutes, 4.09 seconds every single day for thousands of years. And you ask yourself the question, is that really possible for a planet amidst this big, humongous universe with all its forces and external forces, cosmic forces, and then internal forces like earthquakes, tsunamis, volcanoes, you name it. We've got 1 million earthquakes a year on the earth, okay? Each of those have enough inertial power, according to Newton, to retard the rotation of the earth, okay? Now, if you add all those millions of earthquakes per year times thousands of years, 5,000, 6,000, however far you want to go back, and all the other internal, the plate tectonics where plates are moving against one another. Every time somebody builds a big building, it's supposed to slow down the earth. There's tidal action, tidal waves. We have 2 tides a day, and that's another inertial force that the earth has to put up with. If you add all these together, and I've calculated them all, there's probably about 15 of them just internally that the Earth would have to worry about in order to keep the rotation constant. Okay. And then you got some external ones, like you got the perturbations of the planets because of their gravity. You have the moon's gravity, you have the sun's gravity, you have cosmic rays coming in, you have meteors, you have asteroids, you have all kinds of things out there that could disrupt this rotation. And yet it stays the same, 23 hours, 56 minutes, 4.09 seconds. How is that possible? It's not. Okay. That's why we find planets like Saturn slowing down in its rotation, or Venus slowing down in its rotation. A lot of the planets don't rotate, so we can't figure them in this. But that's what I would see. I would say, wow, so what makes the day so precise for thousands of years without changing? There's only one way it's going to work out, in my view, and that is if you got this humongous universe rotating around a fixed Earth, and this universe has so much momentum that nothing can stop it, either from the outside or the inside. So it's going to continue ad infinitum, this constant rate of rotation that a little tiny Earth, this little pea in the midst of this big C universe, could possibly never do, you see. So God put the Earth in the center for a reason, because it's the most stable place for biological life to live and produce, you see. That's the way I see it. So I don't think the intelligent design work is going to be able to be reversed. I don't think an intelligent designer would ever go in that direction.
Gotcha. Thank you so much. Over to you, Dane.
Yeah, so I actually wanted to kind of keep going down that train of thought around the Earth and its motion or lack thereof, right? So we've of course all been taught that the Earth is rotating on its axis. Simultaneously, it's revolving around the sun at 66,000 miles an hour. At the same time, the sun is being pulled in the galaxy. So then you add that speed on top, and then the galaxy is moving through the universe. So we're moving supposedly in about 4 different ways at really great speeds, just as fast as you could imagine. And also, it's not even a perfect circle; it's an elliptic, right? That's the story, at least. And so here's where I'm going with this. With all of those types of motions, it seems like a clever scientist should be able to figure out an experiment to detect the Earth's motion. And I'm kind of leading you up to talk about Michelson-Morley, but has that ever been detected? Has science ever actually proven that the Earth is moving?
No, and you'll find them admit this in their books. And this was the intriguing thing to me when I did the research. They all recognize that they have no scientific proof that the Earth is moving. At least the experiments they did with light. And you're talking about Michelson interferometer, 1887. You're talking about George Bedell Airy's 2 telescopes using light from the stars in 1871. You're using Dominique Arago's experiments with starlight back in the 1815s and to 20s. They recognize that whenever they use light to try to measure the Earth moving, it doesn't show anything. Okay. They like to use light because it's so fast. Okay. And now before, they've had experiments like, the Foucault pendulum. Okay. What else would they have? That was the most famous one, 1865. They've had other experiments like stellar parallax, stellar aberration. These are movements that the stars give against the Earth. And you're figuring, well, you should be able to tell whether the Earth is moving or not, because if the star is moving a little bit, well, maybe it's not the star that's moving, maybe it's the Earth that's moving. That was their logic. Okay. So we just reverse that logic. Basically, we say, well, how do you know it's the Earth moving? Maybe it is the stars moving. Okay. So that's not going to give you proof. Neither is the Foucault pendulum, because if the plane of the bob of the pendulum is the changing angle, well, that could be due to the rotation of the Earth, but what's it going to be rotating against? How is it going to know that it has to change the angle just because the Earth is rotating underneath of it? So that's not a complete explanation. Maybe It is that the gravity or the forces of the universe itself, best represented by the stars themselves, which are in the 22 septillion range. It's a lot of stars. Maybe they're pulling the plane of the Foucault pendulum. Okay. So as science has gone, they've seen that a lot of their interests were amateurish. They were just guesses because they didn't know what was out there, about the stars. Even Newton didn't know what the stars were. Nobody knew what the stars were. Not until the 20th century did we figure out, oh yeah, they're burning balls of gas just like the sun is, and some are here, some are there, and they may affect us. You see, that wasn't until Ernst Mach came along, right around the time of the Michelson-Morley experiment, where they began to look at the universe as this entity that may have some effect on us. And this, before I get into Michelson-Morley, this is the key to understanding geocentrism, if I may. Okay, is that this idea that we're all by ourselves in this little solar system, and that we can forget the rest of the universe. Okay, that was the going mentality with Copernicus, Kepler, Tycho Brahe, and everybody at that time. Okay, now here is the thing that changed everything when Newton came along, because a lot of these guys that I just mentioned, Copernicus, Galileo, Kepler, they weren't using mathematical equations. Maybe Kepler had a couple, but nobody was seeing the thing, and let's put that into a mathematical equation so that we can really show that if math supports it, then it must be viable. Okay. The first guy to do that, to really start doing that, was Isaac Newton. And he wrote this equation down. And tell me if you've heard of this before. It's called F equals ma. Anybody here heard that? Okay. So that's force equals mass times acceleration. And everybody was just so proud that they had this equation. And he used it for the heliocentric system. He said that you have this mass, the Earth, and it has to accelerate around the sun at a certain acceleration in order to stay away from the sun that's going to pull it in by its gravity. Okay. And you can prove it by F. That's what F equals ma means. And everybody was like, wow, for the first time in history, we understand how everything's put together. It's this equation that makes it all work. It was like the theory of everything equation back then, So, and the way that Newton got there was to think of the universe as inert, absolute. If it's absolute, it's almost like infinite. It can't move. It can't do anything. It's just there. Okay. And this is where he developed his idea of the straight line. Now that may seem like a sort of elementary thing, but it's actually the key to understanding this. He draws a straight line on the blackboard, okay? And, I can just imagine doing this in a lecture on geocentrism. And I draw a straight line, and I say to everybody, is that a straight line? And then I got him thinking, okay? Because now they're asking, well, why is he asking us if this obvious line is a straight line when it actually looks obvious that it's a straight line? And the reason is because Newton needs that. He needs that absolute concept of straight line, because that's what he said the Earth would be doing if the sun wasn't present. That the Earth would be moving in a straight line, and the reason it could move is he called inertia. It has inertia, so once you make it move, it moves, but it's not going to move in a curve. It's going to move in a straight line. Mm-hmm. There has to be another net external force to take that Earth and pull it away from that straight line path, and that's when it will curve. Okay, so this is important because what does it show? Well, it shows that Newton is not regarding the universe, the stars, or anything in the universe as having an effect on this little model that he's made. It's just the sun and the Earth. Okay, and you can include the other planets, but they're all going to do the same thing. So Newton limited the scope of scientific investigation to the solar system. And if you do that, we would all be heliocentrists today. There wouldn't be any show right now discussing whether this is possible or not. Because if you only have the solar system, yes, the Earth has to go around the sun. So when you see the sun going across the sky every day, you know that must be the Earth rotating. Okay? Because there's no other solution. Okay? And everybody for 200 years said, wow, we finally got the answer. And the church, the poor church, who was sticking up for the history of it for what, 1600 years, this guy Newton comes along and basically with one hand just slaps the church in the face and says, you fools, you see what we found with this equation and blah, blah, blah. And they were reeling. The church was reeling, but she kept the faith. It's amazing to see how much she kept the faith. Because nobody knew what I'm going to tell you back then. Okay. If I told them what I'm going to tell you, it would have been easy. They would say, oh, yeah, that makes perfect sense. So, the church was right for the past 1600 years. No problem. Thank you, God, for giving us that information. It confirmed our condemnation of Galileo, you see. Because back then, Robert Bellarmine, he didn't have the science we have today that I'm going to give to you. Yeah, he's just going by the word of God. Hey, the word of God says the earth doesn't move. Period, case closed. That was his attitude, right? And Galileo's arguments, of course, he had none. So there was no proof on his side. Right. But then somebody comes along 200 years after Newton and says, what right did Newton have to leave the rest of the universe out of the equation? None.
Question.
None. Okay. So that puts us on a whole different setting, doesn't it? We're on a whole different stage now. Okay.
Mm-hmm.
And that's where we see that by the time Einstein comes along after Mach, and they were colleagues, and both came to the same reasoning together, things were not based on the straight line anymore. The straight line of Newton was taken away. And now they recognize the curvature of the universe. Okay. And that's why when you read Einstein, you read about curves and all that kind of stuff, and the gravity makes the outside part of the planet pull in a curved way around the planet, all that kind of stuff. It's curved geometry called geodesics. Okay. And at least now, sometimes they went off in the wrong direction with this stuff, but at least they showed that you can't run the universe by a straight line.
Mm-hmm.
Okay, that's over. So what does that mean? And if you include the rest of the universe, then you're in a whole different realm, and you have to figure out how straight lines and curved lines coordinate together to make a universe. And now, okay, that gets pretty complicated, but it does this. It takes us away from this old Newtonian idea to the new relativistic idea, which brings us right to the door of geocentrism, as I told you before. Because if you believe in relativity, you have to believe that whatever model you set up, there's a reciprocal to it in relativity. Okay. And just like Father Lemaitre found. Okay. So that's pretty much the history in the physical sense, the physics of it. Do you have any questions about that or anything? Want me to develop anything?
Yeah, I think I've got some follow-ups. Before that, though, I do want to remind our audience that if you have questions for Dr. Sungenis, you can put them into our chat. And if you super chat a question, it will get first priority, and you'll be helping support this ministry at Faith Unaltered. So we will give super chats first priority. But yeah, so that was definitely a lot to think about, and it's all very interesting. And I did want to go back to Michelson Morley in case we want to explain what they did in their experiment and how the results were baffling to the people holding up the Copernican principle. And then a lot of what Einstein was doing with relativity, is it true that that was kind of in response to the Michelson-Morley and trying to figure out how to explain away what we saw there?
Yes.
Okay. If you
Because
want to
look,
dive into that, that'd be great.
he's just like you and the rest of the people, or me and the rest of the people. He's grown up with this idea of Copernicanism, and he thinks it's right. He doesn't know how he can prove it, but he thinks it's right. Okay? Because not only does he think it's right, but he thinks it's right because the alternative is that the earth is in the center. And if the earth is in the center, God exists, and God's going to judge him for his life, which was sordid, to say the least. Okay? If you know anything about Albert Einstein's life, which by and large has been kept from the public. You got to dig real deep to go find out all his little peccadillos, let's say.
All right.
Yeah, and there's a lot of them. So these guys know, because Jesus says, why don't they come to the light? Because they love the darkness and they don't want their sins to be exposed. Simple answer, right from the mouth of Jesus. Okay. Yeah. And so that's what we're up against. Men who they want to deny the existence of God because they don't want their sins exposed. Okay. That's all it amounts to. So they'll do anything, whether it's science or music or politics or whatever. They'll do anything they can to get this idea of God out of here so we don't have to worry about it. Okay. And Einstein was among them. And so he had a lot of incentive to try to answer the Michelson-Morley experiment because it looked like that experiment was showing the Earth wasn't moving. And if it ain't moving, then that means it has to be in the center. Yeah, there's no other options out there. Okay. Yep. The thing that doesn't move has to be in the center. Everything else moves in a circle or a sphere. Okay.
And so, yeah, I was going to say, so what Michelson-Morley were doing is they were shooting light beams in the direction of where the ether was supposed to be coming towards us, right?
Yeah, I was going to get to that in a second.
Oh, okay. Sorry, I'm rushing you. I shouldn't rush you.
I'll go there because I know you're biting at the bit to hear that. So I'll go there.
Cool.
All right. So the idea is, if the Earth is moving, and how can we measure how fast it's moving and if it's moving? And so they devise an experiment, a very ingenious experiment, wherein if you take a light beam and you shoot it in the direction you think the Earth is moving around the sun, and that would be counterclockwise. Okay. So the back of the Michelson-Morley experiment would not be pointing in the direction of the Earth's supposed movement. The front of it would, and they shot that light beam into that direction, and then they made it bounce back. And you can do that if you just make your interferometer, let's say, 10 feet long. You just shoot it 5 feet that way, and it's going to bounce 5 feet back to you. But it did go in the direction that the Earth is supposedly moving, you see, at least for 5 feet. Okay. And then you get a control light where you don't shoot it in the direction that you think the Earth is moving. You shoot it up or down, where there's no effect at all, because the Earth is not moving up or down. It's only moving in one direction, counterclockwise, laterally, counterclockwise. Okay. Now, they believe that there was ether in space. There's a substance in space. They called it ether because they didn't know what the heck it was. You could call it ether or schmether or whatever you want to call it. The fact is, they believe something occupied space because space could not be empty. Okay. Because you can't say, there's nothing out in space. Why can't you say that? Because nothing doesn't exist. The very word nothing means there's nothing there. Okay.
Right.
So there has to be something there. We don't know exactly what it is, but it's something, not nothing. Okay. And they all believe that. From the Greeks onward, they all believe that. There's Democritus, and somebody else is having an argument. He says, well, there's a void out there and there's atoms. And the other Greek says, well, if there's just atoms and a void, well, the void means there's nothing there. And if that's the case, then the atoms would be touching each other, you see, because you can't have a nothing between them. That's not a nothing. You have to have something.
Even space is something, right?
It's something, yeah. And we found out today, you see, this is the new knowledge I was talking about, that, yeah, we can actually go detect what's in that space now. We have that ability, okay? And you'll find out about Einstein, how contradictory he was, because in the first instance, he rejects the ether, and then 10 years later, he takes it back. He takes it back. So this is all stuff the public doesn't know, but I do because I did the research. At any rate, in the Michelson-Morley experiment, this was the key. How can we find out the Earth going around the sun? Well, we shoot that light beam in the direction that the Earth is supposedly going and measure it against a control beam, and there should be a difference. There should be a difference. Now, there was a little difference. Every time they did the experiment, over 50 years, by 12 different experimenters, everybody always found a little difference, but not nearly enough to commensurate with an Earth revolving around the sun.
Mm-hmm.
Okay. They would get like a 3 and they needed a 30.
Mm-hmm.
Okay. And this would happen every time. And I can explain why they got the 3, but I'm not going to do it here now. But they never got the 30 kilometers per second that they were looking for. Nobody over 50 years. This has been the most repeated experiment ever done in the history of science.
Wow.
Yeah. From 1881, when Michelson first did it, to 1930, when a guy named Joos did it, Joos. And they all found the same thing, that there wasn't enough resistance from the ether to say that the Earth is going around the sun. Okay. So what should the conclusion be? It should be
the Bible was right and that the Earth doesn't move.
Right. And as a matter of fact, the literature shows that. They knew that a non-moving Earth is a legitimate explanation to that experiment. And then the next paragraph or sentence will say, but we don't like that interpretation. That doesn't fit in with our paradigm, our beliefs, our this, our that, you see. And so now we make a philosophical judgment. We'll find some other way to answer that experiment. And lo and behold, Albert Einstein comes along, and this is what made him famous. This is what the special theory of relativity is all about. He admits that he came to the special theory of relativity because of the Michelson-Morley experiment. Okay? So if an experiment shows the Earth isn't moving, and some scientist comes along and says, well, I can explain to you why it looks like it's not moving with this theory called special relativity, how famous do you think that's going to make him? They're all going to bow to his feet and say he's the greatest scientist the world has ever known, because he kept us away from this fixed Earth idea that was back from, the Stone Age. Okay. We've advanced since then. And so we don't have to throw away 500 years of science that has developed since Galileo, because Albert Einstein saved us from that. Okay. So you can see what's going on. There's a lot of psychology and philosophy going on in science when they give you this impression that it's just men in white lab coats doing experiments, right? And being very objective. No.
Well, right. Like the Hubble quote that you have in the Principle documentary, where he says the discovery, and this isn't about Michelson-Morley. I think this was with the cosmic radiation background, something like that. But he says this is an unwelcome discovery. It's like, wait, I thought science was just about the data, but he says this is an unwelcome discovery.
Yeah, he has about 6 different words he uses in that book.
Yeah.
1937, he wrote. Intolerable is another word that he used. This cannot be. We cannot accept this. And he goes on and on for pages, like he's I don't know.
That shows the psychology and the emotion there.
Yeah.
So I don't want to derail your thoughts. So Einstein has to react to the Michelson-Morley, and what does he do in reaction to it?
All right. So what he does is he you have to know this little bit of history before I can tell you what Einstein did. There was a guy that came along 5 years after Michelson did his experiment, and his name was Hendrik Lorentz, a Dutch physicist, well-known, world-renowned Dutch physicist. And he said, okay, this is what I think is happening with this Michelson experiment. He says, as the interferometer, that's the measuring device to see if the Earth is moving, it's discharging this light beam. Well, as the interferometer is going with the Earth around the sun, it's receiving pressure from the ether that's making it shorter than it was before they started the experiment. Okay, so what he's saying is that the Earth is moving around the sun, and the reason we can't detect it is because the machinery has been altered by the very ether we're going through. Okay, so, and if you shorten the arm of the interferometer that's making the measurement, it's going to look like the Earth isn't moving. And he knew exactly how much he had to shorten it by in order to make it look like the Earth wasn't moving. And he came up with an equation. And this equation is the new length equals the old length times the square root of 1 minus v squared over c squared. Now that looks complicated, but all that square root business means is it's less than 1. It's always going to be less. It's always going to be shorter if you move it than if you don't move it, is what it amounts to, right? So Einstein comes along and he doesn't like the ether idea. Got to get rid of that. Why? Because that gives an absolute. And I'm not looking for absolutes, man. I'm looking for relativity. Okay. So he gets rid of the ether, and because of that, and he says, now here's what really happened. I like the idea where Lorentz says that the interferometer was shortened. Okay. But I'm not going to put a cause on it. I'm not going to say it was the ether putting pressure on the interferometer arm. I'm not going in that direction. I'm getting rid of the ether, and I'm just going to say, look, this is the principle of nature, that if something moves, it's going to shorten. Okay? So he says, I'm going to borrow Lorentz's equation because it works. Okay? But Lorentz had used it for a totally different thing, because Lorentz has said that the ether is putting pressure on the interferometer arm. Einstein says, well, I don't need ether to do that. It just happens. We just have to accept it. Okay? And there were a lot of philosophers around that time that were saying that Einstein was contradicting the laws of metaphysics, where he's having an effect without a cause. Okay, so, hey, but look, the goal is to keep the Earth moving. As long as we can do that, everybody's going to be happy, and we don't have to go kiss the feet of the Pope. Okay.
I'm sort of curious because you're talking about here Einstein and special relativity and. It's something that I've come up with, right? Where the measuring devices themselves are being affected as you approach the speed of light and that sort of thing. But some other philosophers like William Lane Craig and myself, they've applied this to the theory of time and said that, well, this proves that, time isn't relative in the way Albert Einstein. What are your thoughts on special relativity, and what are the implications for the nature of time in your view?
All right, so here I'm glad you asked that question. Does that now you've just opened a can of worms that you should be able to see the whole fallacy of this thing. Okay, so if you claim that the length of a moving object is going to shorten or it's going to contract, okay, and you had planned to send that object from point A to point B, okay? That object's moving along. He's going from point A to point B, okay? Now, let's say that object is 2 feet long, no, 2 inches long. Doesn't matter. I'm just trying to make it easy. So
you should use the metric system. I am a Canadian, so.
Oh, okay, sure. So it's
oh gosh, the Canadians.
it's 1 meter long, okay?
Okay.
And it's going from point A to point B. Now, if you shorten the length of that meter while it's traveling from point A to, because that's what your theory says, that it contracts as it moves, okay? And remember, this is all because they want to make sure that the Earth keeps moving in this Michelson-Morley experiment, okay? So if it contracts, let's say it contracts to, I'll make it big. Let's say it's 95% of the length it used to be because it's moving fast enough to contract that length, okay? You with me?
Yep.
Okay. All right. Now, so the tip, so if that's the case, the tip of that meter, let me get my little ruler out here. English ruler, by the way. So here's my English ruler. It wants to go from point A to point B. but now it's 95% shorter than it was before when it wasn't moving. Okay, so how long is it going to take the tip to reach the endpoint that you had set up before? Well, if it wasn't moving, it would be, it would take a certain amount of time. But now that you shortened it, how long is it going to take? It's going to take a little longer time because it's shortened. You with me?
Yep.
Okay. So now what do I have to do to make everything equal? I got to give it more time. I have to dilate the time, as Albert said, in order to get the tip of that meter to point B as it was supposed to go before we shortened it. You see? So you got to give it more time. And this is where the whole idea of time dilation comes in. This is where it was born, right here. You see, and they kept figuring this out. They were saying, oh my gosh, if we shorten the length, how's that going to affect things? Well, it's going to mean we have to dilate the time. Not only that, they had another thing to worry about. Because if you shorten the length of a meter, what do you do to the composition of the meter? You make it more dense. Okay. And so now, what do you have to do? Now you have to increase the mass of the meter in order to make all things equal by the time it reaches point B. Okay, so you got to change the time, the length, and the mass. And that's exactly what special relativity requires. Okay, if we're going to go through this, guys, if you don't want the Earth to be still in space, here's what you got to put up with. And that's the theory of special relativity right there.
Is this theory of special relativity, is that something that is observable, or is it really just a math problem on a book page?
It's not observable, you say.
Okay.
That's the whole thing. There's no experimental evidence for length contraction. It's a theory.
So
now, it's not just the
Einstein wrote on a piece of paper, basically.
Yeah.
As clever as it may be, it's just ink on paper.
That's right.
Gotcha.
See, his theory was that the ether was compressing it. And Einstein said, no, it's not either. It just happens. We got to put up with it. We don't know what causes it, but that's what happens. And but the thing that grabbed everybody was he put an equation to it. You got a fancy equation. Everybody's going to go, ooh, wow, you got an equation. It must be true,
Equations are pretty, aren't they?
They are, So anyway, that's the story behind that. And I should go on to show how Einstein flubbed that up also. But I it's not that I'm trying to put him down. I'm saying it wasn't for Albert Einstein, we wouldn't be here talking about this. Okay. So, I mean, his blunders across the way, we just take the good from it and we use it the way it's supposed to be used. And everybody's happy now. But as far as this experiment, what was I going to say? It was a funny thing that happened. Well, let me just go on. So Einstein says, no, I'll use Lorentz's equation and make it look real pretty, and everybody has to accept it. And then he used it for Maxwell's electromagnetic equations. And the reason he did that, here's an interesting story. If you know anything about the science of this, James Clerk Maxwell, 1860s, most famous physicist in the world at that time. Okay. He's doing experiments in electromagnetism. And he's got two objects, an induction coil that can generate a current, and he's got magnets. Okay. And here's what he did, the experiment he did. The first experiment, he took the magnet and he moved it around the induction coil like this. Okay. And it generated a current in the electric current in the induction coil. Okay. And he could measure what that current was. So then he took the induction coil and he made it go around the magnet. Okay. And it did put it put electric current in a magnetic field, but they were different. They measured differently than when he did the opposite. You see? When he moved the magnet against the induction coil, he got one result. And when he moved the induction coil against the magnet, he got a different result. Okay. So what does this say about nature? It's absolute. You can't futz with it. You even have to be careful about what you make go around what, because you're going to get a different result. Okay. Now, is that close to relativity or far away? It's far away. Okay. I mean, that just is anathema to Einstein. We got to make everything relative, you see. It's all got to fit together because I'm looking for the theory of everything. Just like today, Hawking was and everybody else, you know. But it's absolute. And so Einstein tried to use Lorentz's equation that Lorentz had developed for, you know, saying why the ether put pressure on the interferometer arm. Einstein's using that same equation to help answer the, you know, James Clerk Maxwell's electromagnetic equations and trying to make them into one equation instead of having two equations. That's how far he wanted to extend his theory, you see. So this is all in 1905. Nobody knows really what's going on. So he doesn't have a lot of challengers, okay? But he started to get a lot of challengers probably 8, 9, 10 years down the road. And there's some questions that had popped up that his special relativity theory could not answer, okay? And so he had to come up with another theory to plug all the holes that were developing in the special theory of relativity. And one of those holes was gravity. How do you deal with gravity? And the other thing would be inertial forces. Okay, inertial forces are centrifugal, Coriolis, Euler forces that are real forces. Okay, that's what you feel when you're on a merry-go-round and the merry-go-round wants to knock you off if you're going too fast. That's a centrifugal force, you see. Coriolis force is a curved force, and the Euler force is a sideways force. So they all have to be taken into account as well. But the main thing was gravity. How do you incorporate gravity into your understanding of the world? Because in special relativity, there was no gravity. He didn't take it into account, or inertial forces. He just had this dream of a pristine environment without ether or anything to impede the speed of the light beam. That's where he wanted to get. Nothing could be out there to impede the speed of the light beam. And what did that end up being as a postulate? That the speed of light is constant. See, you keep hearing this when you're, you know, people hear this all the time. I hear it everywhere I am on the speed of light is constant. This is where they're getting it from. Because if the speed of light isn't constant, then Einstein would never be able to say that the Earth is moving around the sun. The reason he wanted to say that the speed of light is constant is to make light beams unable to measure whether the Earth was moving around the sun. And the only way you could do that is by saying that the speed is constant and can never change. Well, if it can never change, you can't measure anything then, you see. Okay, so
right.
It's hopeless. All right, so that's the kind of environment he wanted for his special relativity to keep the Earth moving, basically. Okay, now keeping in mind that they all knew that a non-moving Earth would have answered this thing very simply, and nobody had to invent length contraction, nobody had to invent time dilation or mass increase, nothing. You see, it was very simple. The Earth isn't moving. That answers the experiment. Okay, but we ain't going there. It's basically what their attitude was.
It's the opposite of Occam's razor. Let's choose the most complicated answer.
Yeah.
Death by 1,000 qualifications.
So, Tyler, Dale, y'all want to jump in with any more questions?
Actually, guys, y'all are making my job easy. Like, I can just sit here and listen to you all day. My godfather, Dr. Bo Branson, said, if you're sitting in a room with people who are just smarter than you, just sit back and listen and enjoy. And that's what I'm doing. But I've got to actually run. So it's my daughter's birthday today. Okay. And we're taking her to a carnival. But you guys keep going. I'm gonna watch on YouTube. And if y'all have any tech issues, I can log in on StreamYard on my phone and fix them if need be. But Dr. Sungenis, it's been an absolute pleasure listening to you and getting to know you a little bit more. I would love to have you back on and actually engage with you with some of this stuff. But sure. I've just been having fun listening. So thank you.
Great. Yeah, love to come back.
Right on, brother.
Right on.
Well, tell Kelsey happy birthday, man.
Will do. All All right. See you guys. Enjoy.
Awesome. Yeah, I
What part of
guess.
the country are you guys from? I
We're all
know,
from different
Dale
places.
from Canada.
Yeah, I'm a Tennessean, and
Oh, Tennessee.
Tyler's Indiana, I believe.
Oh, okay.
Yeah.
Yeah.
Where are you at?
I'm in Pennsylvania, southern Pennsylvania.
Okay, right on. Yeah. So Dale, did you have any follow up? Because there's a few other things I'd like to talk about before we run out of time.
Yeah, so not a follow up on that, because I think Robert was just answering my last follow up, but something else related to the science. I'm kind of interested in evidence that you think can actually support the geometry. So it's one thing to kind of attack Einstein's interpretations and say it doesn't make sense and stuff like that, but is there actual empirical evidence? So, for example, I know that some people that take your view have argued that the redshift data can actually be used to demonstrate geocentrism there. So, do you want to go about that? And same deal with the cosmic microwave background radiation. I think Dane mentioned that earlier, but that can also be used. So, like, how do these possibly support the geocentrism model?
Yeah. So, redshift, I'm glad you mentioned that, because that's basically right after Einstein. That's the second stage, was the redshift issue, and this goes right back to Edwin Hubble that we were talking about before. Okay, so Edwin Hubble, he's in 29 now, great astronomer of the world. He finally has a very big telescope to look at the universe with, the Mount Wilson telescope, 100-inch lens telescope. I mean, that's just phenomenal what those guys did to make that lens, because it has to be perfect. If there's any flaws, you won't be able to see crap out there. Okay, that's what they found out when they sent the Hubble Space Telescope. Somebody did make a mistake, then they had to redo the whole thing. Gee. At any rate, Hubble has his telescope, his Hubble telescope on the Earth, not the space telescope, of course. And he's looking all around at the galaxies, and he sees thousands of galaxies, thousands. No one had ever seen a galaxy before, but he's seeing them all right in front of his eyes. And it's beautiful. And he realizes how big this universe is. But then he starts to do some study on these galaxies, and he notices that all the light coming from these distant galaxies is all shifted to the red end of the spectrum, which we call redshift, right?
Yep.
And he knows. You have a question? Did you have a question?
I was just agreing with you.
Oh, okay.
Sorry.
So he knows from that evidence that if he all he sees everywhere he looks, north, south, east, west, down, up, left, right, is just redshift, what does that mean? That means the Earth is in the center of the universe. He says that in his book. Okay. And Hawking comes along later and confirms this and says, yeah, because if we weren't in the center, we would see some blue shifts in addition to the red shifts. Okay. But if you see just red shifts, that means you're in the center. So he says, we can't have this. Okay. Because we all believe the Earth isn't in the center, number one, right? And what does this do to us philosophically? Well, it turns things topsy-turvy. We don't want to go through that, do we? All right. So we got to figure out some way to make it look like the Earth is not in the center of the universe. How are we going to do that?
Can
so
I
poke? Go ahead.
Yeah, just a quick follow-up. Sorry to interrupt and stuff, but you mentioned that like there are no galaxies out there that are being blue shifted. My understanding is there are a couple that.
Well, they're local galaxies. They're not distant galaxies. Like Andromeda, for example, is a blue shifted galaxy, but that's called our local neighbor.
Okay.
There are no galaxies, distant galaxies that we're talking about that are in the blue shift. Okay, so we know that for a fact. If somebody finds someone out there, great, but that hasn't been till this day. So the fact is, you got all these galaxies redshifted. That means we're in the center. How do we get rid of this idea that we're in the center? Here's what we do. We take away the center. And you can do that if you switch from Euclidean geometry, that's based on 3 dimensions, to what they call Riemannian geometry, that's based on 2 dimensions. And in that geometry, all you have is a surface. And it's like a balloon. A balloon has a surface, doesn't have a center. Although somebody can say, well, there's air in the center, but that's not the balloon. The balloon material is a surface. Okay. And what we'll do is we'll put all the galaxies, including the Milky Way, on the surface of that balloon, and then we'll blow the balloon up and we'll let it expand. And if it expands, then any galaxy that looks at any other galaxy is going to see what? He's going to see the light redshifted, because if you separate the emitter from the receiver, you're going to have a redshifted light beam. Okay. And so that's how they got out of it. And that's how we have the Big Bang universe, because it's a surface that's expanding. But now they're having trouble figuring out how it expands. Where's all the energy making it expand? How fast is it expanding? All that stuff that they're having to deal with. But nobody thought of that back in Hubble's day. You see, they had the model, they were going to use it, and then we'll just make it fit somewhere down the road if we have difficulties, which is where they are today. Okay. But so redshift it's actually one of the greatest supports for the Earth in the center of the universe, because that's what we see out there. And even the astronomers themselves know that that's what puts the Earth in the center. Okay. So redshift by no means is going to be a way that they can say we're not in the center. If they knew their history, they would say just the opposite. Okay. Now, if you want to deal with the cosmic microwave radiation, this is another thing. They've had this, there's basically 4 radiations. You've got the dipole, the quadrupole, and the octopole. And then in between that is this thing they call the axis of evil. Okay. Have you heard that term before? Axis of evil? Okay.
Yeah. There's
so basically
no bias, though. No bias whatsoever. Naming it the axis of evil.
Yeah, right. I guess that's where you should start. Why the name of the axis of evil? Because what it does is it shows that there's a direction in space, as if somebody drew a line from one end of the universe to the other end of the universe. And that line happens to go through the ecliptic plane of the sun and the earth. Now tell me that doesn't affect you. What in the heck is the orientation of the whole universe orienting itself around the sun-earth ecliptic, for crying out loud, which is 23 and a half degrees from the equator. Okay. And so the way they try to prove this is they say, well, let's just take the dipole. That's the radiation that's running from the west of the equator to the east of the equator. And we verify, or we think that the Earth and the sun are moving through that at 371 kilometers per second. That used to be the going theory, how you explain this dipole radiation, right? But like you said at the beginning of the show, Dan, I don't think you even realized it. You were saying they have all these radiations coming from different directions at different speeds. You remember saying that? Mm-hmm. Well, that's what they found since that time, that you can't say that the Earth is moving through the CMB, because there are many CMBs going at different speeds from different directions of the Earth. Okay. And so how could you explain that with one Earth going through the CMB? You can't. You have to. So that theory has been blown now. Okay. You can't say that the Earth is moving through the CMB. So, but they still have this axis of evil to deal with. How do you explain that? In a universe that came from a Big Bang, it should be homogeneous throughout and isotropic with no distinguishing marks anywhere. Okay. And yet we have this line going through. Now, we'll all admit the temperature differences aren't that great, but they shouldn't be there in the first place, no matter how small they are. But they just happen to be small enough along this line that goes from one end of the universe to the other, cutting right through where the sun and the earth are. Okay, so this is going to puzzle them forever. They're not going to be able to explain it. And see, what they do is they'll put it on the shelf and they'll go, well, we'll wait for the next explorer to come along, and then things will be solved. That's how they handle it now. We'll just put it on the shelf for now, and hopefully we'll have better and more accurate instruments to go check to see if this is correct or not.
Yeah. And that's really interesting. I mean, I find the what you're talking about there, the cosmic radiation background, I find that to be extremely compelling evidence that something's going on here. And then once again, Hubble talks about intolerable and unwelcome data. This data is called the axis of evil. You really do start to see a clear bias in the scientific kind of establishment community. But hey, before we move on too much further, we do have some questions, and this one directly is linked to what you just talked about. So Spartan Theology is wondering why you kind of can hand wave the blue shift of these more local galaxies, these neighbor galaxies, asking, how if we're gonna say that other scientists are just finding evidence to fit their presuppositions, how is your saying, well, it's not a big deal when it's a blue shift in a local area? How is that different from, just fitting evidence with your presuppositions?
Because we could say, along with everybody else, that the Andromeda galaxy that has a blue shift is moving toward us. We can say that because why? We know things are moving out there. Whether they're moving away, sideways, forwards, backwards, it's all different. But we have no problem in saying in our local arena, there are things that may be moving toward us. Okay. But that's not how you determine how the universe is acting. You see, the universe is, 1 billion times bigger than our local group of galaxies. So that's where you have to rest your judgment. And when you find out they're all redshifted, well, that makes a difference.
Cool. Thanks for that. So there's a few more kind of science things I want to talk about, and then I do have a few like theological things I want to talk about, and I'd like to leave time to answer a few more audience questions. So maybe do one more kind of sciencey thing, and then a little bit of theology, and then we'll wrap up with some audience stuff.
Well, if I could ask and indulge you, can I finish the Einstein story in about 3 minutes?
Yeah, for sure.
Because we need to put the cap on that.
Yeah, let's do it.
All right. So he's seeing all the flaws in special relativity. He comes up with general relativity. What does general relativity do? He takes back the ether that he got rid of in the special theory. And what does that mean? Well, that means they have no answer for the Michelson-Morley experiment. Remember, the top explanation was there's no ether. All right. You just came back 10 years later and said there's an ether now. All right. So what about the Michelson-Morley? Oh, well, we're not going to worry about that right now. Okay. I just put it on the shelf. Okay. So we've been without an answer to the Michelson-Morley experiment for the last, 100 and so years. And nobody's noticed. Okay. All right. So that's the second thing. What else happened? The speed of light is no longer constant. It can go at any speed. Okay. Now, diametrically opposed to the special theory. Now, granted, the special really didn't have ether. Okay. And now it does have ether. And okay, so the speed of light can't be constant. But nobody sees the contradiction. It's like, come on, people, wake up. One theory says light is constant and there's ether, and the other says there is no ether. The other says there's ether and light is not constant. All right. So we've got a big problem, but nobody wants to spill the beans. Okay. They'll just say, well, we can use whatever theory we want at the time. That's how they do it. So it takes back to ether. Speed of light is not, and the speed of material objects is not limited either. Why? Well, because if your general relativity requires that you give the reciprocal, and that means that you have to have the stars going around the Earth once a day, well, they're material objects, aren't they? Mm-hmm. And if they're going around the Earth once a day and they're very far away, that means they're going way beyond the speed of light, right? They would have to. It only takes 24 hours to go around the Earth, and they're, 65 million light years away. They better be going pretty fast around. Okay. But that's what Einstein said. Yeah, that's what the general theory says. They can be going that fast. Okay. So now we have just a complete shift from the limitations of special relativity to the open-endedness of general relativity, you see. And that's where it ends. Then he dies. And before he dies in 1922, they thought he proved his general relativity theory by the eclipse data. Okay, so that further cemented general relativity into the conversation. Nobody was going to get rid of that. And, then we go on. So I just wanted to put that little cap on there.
Yeah, thank you for that. That's it really is interesting to see how we're trying to piece things together. And if there's one point that the audience gets from this video, I hope it's this. You're seeing that a lot of the cosmological sciences are not quite as based on observation as we're led to believe. A lot of philosophy is coming into it, a lot of just math, which math is good, but it's only pen on paper until you actually observe it in the real world,
Yeah.
whatever these equations are. So I hope people will see that, whether it's Einstein or anybody else.
The irony of that, Dane, is, remember we talked about Hubble and all the words he used? Well, the title of his book where he uses those words is called The Observational Approach to Cosmology.
That's so funny. Yeah. Irony upon irony, right?
Yeah.
Dave, is it okay if I ask one last scientific-based thing before we go to theology? Is that
so it may be the same one I wanted to ask. I had one more kind of science question as well.
Okay.
I wanted to touch, and if it's not the same one you had, Dale, we can do two more on that, and we can try to keep the answers sort of short to leave some time for the theology. But I was going to ask about the concentric shells and the way that the galaxies around us have been mapped. So, Dale, was that the same one you had, or did you have something else?
I had something else that's
Okay.
Not on the list, but I do see some people in the audience asking it. So, yeah.
Okay, how about this? If you can give a real quick answer about what the concentric shells is and the map of the galaxies and how it's good evidence of geocentrism, and then Dale will have one other question as well.
All right. So in 2001, they did a study of over 400,000 galaxies. It's called the Sloan Digital Sky Survey. And they still use it today. It was an amazing study. And in that study, they found if you know how to categorize and group these things, and a lot of mathematics is involved, you see concentric spheres of galaxies centered around our galaxy or our Earth, okay, to the tune of each shell is 250 million light years apart from the previous shell. And they go out into 7 shells. Gee, 7. Wow. Okay. So there's 7 shells, and each shell has the maximum amount of galaxies that it could contain. And between the shells, there's hardly any galaxies. There are some, but not enough to make an impression, to be prominent. So in other words, there's 7 prominent shells of galaxies that surround us. We're in the center of it all. And this was part of our movie, The Principle. John Hartnett had done a lot of work on this and did all the math, as a matter of fact, and showed how this was possible. Now, interestingly enough, in that diagram that I helped create with John for the movie, they have what they call the Great Wall of Galaxies, okay? And there's no match for it on the other side of the image. You have galaxies, but they're not as big as the Great Wall of Galaxies, and it's on one of these shells, okay? So what does that tell us? That tells us that the galaxy count in the universe is lopsided. This has been confirmed by other studies, that not by much, but by just enough to create an imbalance of the mass, okay, so that it's not perfectly balanced as a sphere, okay? Now, this is good for geocentrism. Why? Well, here's where we need to make a couple of distinctions. The scripture, for example, never says that the earth is in the center of the universe. That's been our interpretation, okay? Scripture never says. What does Scripture say? Scripture says the earth doesn't move. All right, so that creates a whole different kind of outlook, because the geometric center of a sphere is never going to move. Well, I can't say it's never going to move, but what we can say is it's equidistant from any circumferential distance you want to measure it. That's why it's called the geometric center, Okay. There's another center, however, called the dynamic center. The dynamic center is created by how the mass is distributed in that sphere. And if you got more mass on one side than you do the other, the dynamic center is going to go toward the place where you have more mass, not less mass. Okay. So the dynamic center doesn't have to be the geometric center. Okay. But what we do know is the geometric center, if that thing rotates, that sphere rotates, has to go around the dynamic center. We know that from physics, you see. It's not the geometric center that everything's going to go around. And so what does this do? Well, this explains why the CMB, cosmic microwave radiation, is centered around our ecliptic plane with the sun, not just the Earth. Why? Well, because in geocentrism, the sun is the geometric center of the universe, and the Earth is the dynamic center, or what we would call the center of mass. Okay? And it's not going to move because of that. The whole definition of center of mass is that the center of mass doesn't move. But that means the geocentric center can move, you see. And it's geocentric. Why? Because all the stars are aligned around this geometric center. And so the sun and the stars can go around the dynamic center of the universe, you see, just like we claim. And why? And how do we back that up? Well, because there's an imbalance of galaxies in the universe. And what does that cause? That causes a precession. Whenever you have, if you know how a gyroscope works, like you ever see those toy gyroscopes you place on the table and you pull the wheel and make it go fast, and you place the gyroscope on there and it stays straight up and down, right? Well, if you were to poke it a little bit, what would it do? Well, now it starts to go, it precesses, you see, it precesses. And that's just like putting more mass on one side than the other, because it's going to create an imbalance. Like a tire that doesn't have the weights in the right place, what's it going to do? It's going to wobble because the dynamic center doesn't jive with the geometric center. They're not in the same place. And if that's the case, the tire's going to wobble. So you got to bring it to your mechanic, and he puts the right weights on there to make it all balanced, you see. But that's the way they're finding our universe is built, with a few more galaxies on one side than the other, which helps us in our understanding of geocentrism.
Very interesting. Thank you for that. Dale, let's do one more science question and then we'll move on.
All right. This is just a very simple one, but I've seen it in the chat, and it was something that I was thinking of as well, because in terms of the geocentric model on the solar system, and it's not just a bunch of math. We have satellites out there. We have actual people out there from all walks of life. Like, I was watching Answers in Genesis video. I don't know if it was Dr. Jason Lyle or it may have been someone else, but they knew personally a Christian person who was an astronaut who went out, and they can prove, I mean, number one, it takes these precise calculations that only work if the Earth is moving around to get them where they need to go. And they are making observations consistent with a heliocentric model. So like, what do we do about these kinds of observations from people, not just atheists or something like that, but even Christian astronauts and stuff?
Yeah, well, and I know the astronaut they're talking about, and I've talked to these guys about that. And they swear we went to the moon because this Christian astronaut says we did. So I know where all that's coming from. But dealing with the issues of the equations. Okay, now let me tell you the truth that they're not probably going to be willing to tell, or may not even know. Okay, when JPL, NASA, all the other kind of space agencies send up satellites, what frame do they use? They use the Earth-centered frame. They don't use the solar barycentric frame. Why? Because it's a lot easier. It's a lot easier to do the math with the Earth-centered and not moving than it is trying to figure out all the movements of the sun and the Earth and the planets in your calculations. Okay, that's number one. You can read about this in my book. I've studied it very thoroughly. They got two Earth-centered frames that they can use, ECEF or EC. I forget what the other two letters were, but there's two of them that they use. Earth-centered inertial frame, Earth-centered geometric frame. I think that's what it is. Yeah. All right. So that tells you one thing. The second thing is this. Whenever a person of the Newtonian physics bent is using equations to get a probe from Earth to Mars or wherever it's going, okay, they can't just use F equals ma. Okay. What they have to do is it's F equals ma plus centrifugal plus Coriolis plus Euler forces. Okay. That means they have to add in fudge factors to F equals ma in order to get that probe to Mars. Because if they didn't add in those fudge factors, the inertial forces, that probe would never get to Mars. And so what they're doing is, since the Newtonian mechanics doesn't give them all that they need, they have to add in external factors in order to get that probe to go where it needs to go, is basically what I'm saying. Now, those same inertial forces, centrifugal, Coriolis, and Euler, are the integral part of the geocentric system. Why? Well, because when a universe rotates, it creates angular momentum. And angular momentum is transitioned into the three inertial forces, centrifugal, Coriolis, and Euler. And those forces are what keep the stars in their positions and anything else that's in the universe. Because you would wonder, if the universe is rotating, wouldn't the stars sort of go to the rim of the universe, like you're on a merry-go-round and you're like forced out to the perimeter of the merry-go-round because of the force of the rotation? Yeah, you would think that. So what's the force that's pulling them back or that's keeping them there in their position? That's the Coriolis force. And it's 2 times as great as the centrifugal force, which ends up as a net centripetal force that keeps them in their positions as they go around the Earth every day. And you can find this on Wikipedia, okay? All of it that I'm saying here. It's all in my book. And I even have the date that I got it from Wikipedia so that people can know in case somebody took it down, okay? But what I'm saying to you is the way that the Newtonian heliocentric system deals with getting a probe from Earth to Mars is by borrowing from the geocentric system. They borrow the inertial forces from the geocentric system and they add it to F equals ma, and then they can get the probe to where they're going. Okay. Now, they wouldn't tell you that, or they may not even know that, but that's the truth.
Interesting. Okay. I didn't know that. So, all right. Interesting. Dane, over to you, because I know you want to get to the theological aspects.
Yeah. So and Dr. Sungenis, I don't know how much time you've got. I was thinking we were going to go for about 2 hours. So we're looking.
I'll give you as much time as you want, Dane.
Okay. I've got, I'm thinking we'll stop about 2 hours. So we got about 30 minutes left here. And I wanted to talk a little bit about the theology. So we've thrown out already, the Bible talks about the earth is stationary. Something like Psalm 93 comes to mind immediately, that, the earth has been established and it cannot be moved. And Psalm 19 comes to mind, where it talks about the sun is on its circuit around the earth. And then another one that really comes to my mind is because someone could say, hey, those are the Psalms. That's poetry. Don't take it too literally. But I think we have to take the account in Joshua literally, where the sun stood still for a day, right? And do you think, and I think I know your answer, but do you think there's any legitimate way to interpret these Bible passages in a heliocentric model, or do you think that they demand a geocentric reading if we're going to take these narratives and literally and take these Psalms at face value?
Let me talk to the issue of the Psalms first, and then we can get to Joshua.
Okay.
The Psalms, as somebody tried to say the other day, well, that's all poetry. We don't have to pay attention to any poetry as being literal. Okay. Now, it just so happens that the Psalms are the most quoted book for historical truth in the New Testament over any other book in the Old Testament.
Yeah. Psalm 110 comes to mind right away, right? Yeah.
Oh, yeah.
Yeah.
Yeah. Psalm 1 and many others. Okay. So we got to knock that foundation out somehow, because it's poetry. It's not telling us the objective truth. Okay. That's false. The closest competitor to the Psalms is Isaiah by about a couple verses, as a matter of fact. So now Isaiah is dealing with prophecy. Now, sometimes they'll put it in symbolic language, but it turns out to be historical truth, right? It's fulfilled in the New Testament. Okay. So, and then if you look at the way, say, Psalm 19 is going into great detail about how the sun moves from place to place, why it moves, when it moves, where it moves. I mean, all the 7 wheres and whys are answered in that psalm. It's like, what do we need this detail for if the sun actually isn't moving? Why are you giving me this detail? Who cares? Okay. It's like, so you have to deal with that historical context, and you really can't unless you just take it for what it says. There's a reason why there's 6 descriptions of what the sun's doing.
Yeah.
Okay. And including giving us heat. So now you know it's getting scientific.
That's true. Yep.
So that's how I would do. And I have created many apologetic answers to that issue. But dealing with Joshua, it's a lot easier, because here you have this guy who's fighting this battle against 5 foreign armies, and he's up on a mountain, Mount what's it? Giza, I forget the name of it. Anyway, Mount Gibeon, is it? Yeah.
I'm gonna look it up real quick.
Okay. And so he's up on the mountain with his Israeli army, and the other armies are coming up the mountain trying to corner them. And he's doing a good job, Joshua, of killing them, but he needs more time.
Right.
Needs more time. So he talks to God and asks God to increase the daylight. And God says, okay. And so for the next 24 hours, he has all daylight. And he's able to slay these armies and get the victory. Okay. Yeah. So now the interesting thing is how Joshua describes it, because he says the first time that God listened to a man and did his bidding, and what he did was he stopped the sun in the sky, and he also stopped the moon. Okay. Now there's your clue. All right. Because we know from science today that the moon moves faster than the earth does as it goes around the earth. Okay. As they both go around the earth. And that's why you'll see them separating. If you see stellarium, little exposés, you see the moon and sun separating after days. Okay. Because the moon moves independently of the sun and the earth and the stars. It's got its own movement. It circles the earth every 27, 28 days. All right. So if you stop the sun in the sky, someone could come along and say, okay, well, that we can explain that by the fact that the earth stopped rotating, and it would look like the sun was stopped in the sky. Now, that was Galileo's argument to Bellarmine. Okay, interestingly enough. And I have that in my book. I have all his 10 little arguments, and that was one of them. Okay. Bellarmine doesn't come back with the moon issue, but I wish he had, because it would have put this thing to bed totally. But here's what you do with that. You say, okay, I'll give it to you. Logically, if the earth stopped rotating, the sun would stay in the sky for 24 hours. But what about the moon? Okay. Now, Joshua tells us where the moon is. He says it's above the valley of Ajalon, and that is west of Mount Gibeon. Okay, by I forget how many miles, maybe 10 miles or so. Okay, and it's above the valley of Ajalon. It's about 10 miles from Gibeon, and the next thing west is the Mediterranean Sea. Okay, so if we know that the moon is above the Valley of Ajalon, that means it, and we know that the sun is at 90 degrees. Well, the moon has to be about 30 degrees. Okay. Now, if it's at 30 degrees above the Valley of Ajalon and it's still moving, because why? The moon has its own independent movement. Okay. If it's still moving, what's going to happen? Well, it's going to go into this Mediterranean Sea in about 5 hours.
Mm-hmm.
Okay. But Joshua insists that both the sun and the moon stood still for 24 hours, one day. Well, how can that be? Well, that means God has to affect both the sun and the moon, not just the sun. And so what does that mean? Well, that means that a rotating Earth isn't going to explain the passage.
Right.
The rotating Earth is going to only make it look like the sun stopped, and the moon is going to keep on going.
Right.
So that's why you would interpret that literally.
And you know, something else that has come to my mind with the idea that, well, God just stopped the Earth's rotation, that's why the sun stood still. First of all, the scripture could have just said God stopped the Earth's rotation. That would have been a simpler way to say it. But also, think about what would happen if God just stopped the Earth's rotation. If we were rotating, wouldn't the oceans, spill out, and wouldn't that knock all of us backwards with a crazy force? Like, I've been driving down the road at 70 miles an hour on the interstate and have to pump the brakes, and just that makes my body go, forward like that. Yeah. So if we're pumping the brakes on 1,000 miles per hour of a rotation, that seems like it would cause chaos on the Earth. So that's another place that my mind goes. It's like, no, it's the sun that's getting stopped, not the Earth. So,
I mean, somebody could come and say, well, God will take care of all that centrifugal force and all. Yeah. You can put a lot of things here, but, so that's why you just stick with the text. What does the text say?
Yeah.
The text says no to, having the Earth rotating, be the cause of this issue. Okay. And see, now it brings you to Scripture, because Scripture never says the Earth moves. Never once. Now it says it trembles because of earthquakes. Okay. But that's not a issue of its position in space. That's an internal issue of what's going on inside the Earth, not outside, wherein its position could change from A to B. Okay.
Right.
That's not it. So, and it always says the sun moves. Always.
Right.
Okay. So you've got, come on, man. I mean, the preponderance of the scriptural evidence is there. It's just a matter of accepting it. And pointing to Psalm 19 or Joshua 10 is not going to do anything for you.
And so to actually continue that thought, when we go outside of the scriptures and into the church and how she has interpreted these texts, and especially like the early church fathers, they were unanimously geocentric, correct?
Yes, they were, without exception.
Yeah. Now, okay, so I know that sometimes people will say, well, look, when the church fathers have a unanimous opinion about faith or morality, then that carries weight. But when it's about, something like cosmology or science, well, we can develop that. And I would push back on that and say, well, creation is a core doctrine, right? Like in the very beginning of the creed, we believe in God who made the heavens and the earth, right? And so is this something we can, like geocentrism versus heliocentrism, is this something we can classify as just some kind of science question? Why should the church even worry about it? Or should we say this actually does touch on our doctrines and on our faith and on our practice, because it has to do with God being creator and how he's told us about the creation? So I would wonder kind of your thoughts on that.
Yeah, I deal with this all the time. So the church answered that question. The church said, no, geocentrism is one of those things that we deal with, even though it overlaps with science. Because why? Because Scripture says the earth doesn't move. And God can't lie. Okay? Those were the two metaphysical positions that the church was using to answer Galileo.
Mm-hmm.
God can't lie. Scripture can't lie. Okay, that's it. So the case closed, period. It's done as far as the church is concerned. So now it's just a matter of defending that in any way they could. But let's take the fathers and say, okay, the fathers were in consensus on this idea of, what was it called? Biogenesis or something, where if you had a piece of flesh cut from an animal and you came and you set it in a table in a room and you came back the next day, I forget what the name of that is.
Biogenesis.
Yeah, biogenesis. That's
biogenesis. Okay, so you came back the next day and you saw flies on the meat. You would say, okay, there is spontaneous generation here. I think that's the technical term, spontaneous generation. The meat somehow made the flies, or the flies disappeared. Okay, the fathers believed in that, and so did a lot of other people up until the 1600s, when somebody did some tests and said, no, what's happening is there's little fly eggs in the meat, and when you give the right temperature, they're going to develop into flies. That's why you see them. You see. So, but what if it's a consensus with the fathers? However, why isn't the church saying, well, it's a consensus with the fathers, we're going to have to believe it? Why? Because it's not in Scripture. Scripture doesn't touch that issue.
right.
So it's not a matter of faith. So when the issue that we're discussing may overlap with science, but it is in Scripture, and Scripture can't lie because God can't lie, well, that means it's a matter of faith.
Yeah, that's a good point.
The church told that to Galileo. Okay, that's why it's a matter of faith. And now this is the other part of it, is that in 1633, when Galileo was put on trial, he was convicted of being suspect of heresy. Okay, now that's an interesting little title there, because that means the heresy that he was convicted of had to exist before he went to trial. Because at the trial, you don't say, oh, we're going to make this a heresy and we're going to find out if you're guilty of it.
Right, that wouldn't be fair. Yeah.
Yeah. So when was that made a heresy? Well, that was made a heresy in the time of Paul V, 17 years earlier in 1616. That's when Bellarmine was working with him. And what Paul V did was he hired 11 very erudite, knowledgeable Dominican cardinals to go examine this geocentrism issue and come back and give him their report. They went away for 6 months, and they came back and they said, this is a formal heresy, not just a material heresy. And the Pope took their word, and Bellarmine did as well. And that was the edict from the church. That was the decree. And then 17 years later, when Galileo went on trial in 1633, Pope Urban VIII used the decision from Paul V to convict Galileo of heresy, or being suspect of heresy. Okay, so that's how much it was a matter of faith. It wasn't just a matter of faith that we could sort of, be gentle with you and put it on the shelf and see if it bothers anybody. No, this was big business.
Well, something must have changed, though, between the 1600s and now, because it's not a form. Is it still a heresy or
That's the last official statement the church gave on that issue.
Really?
Yeah, but there's many issues that go by the wayside in the church,
Yeah.
and aren't picked up again until things start to get serious.
Yeah.
And that may happen in the next few years. I don't know. But yeah, they can sit on the shelf for a long time before people actually recognize it.
I'm actually fascinated by that it's actually, on the books, still a formal heresy. That is really, really interesting, really compelling as well. And just so our audience knows, that's the Roman Catholic Church we're talking about. Yeah. Okay, so one other question. This crosses from theology to history. Copernicus, this is an interesting story, right? He recanted before he died, or at least it seems like he might have. Can you tell people the story about the letter that his name was erased from?
That wasn't Copernicus.
Oh, it wasn't Copernicus. Who was that?
That was Galileo.
That was Galileo. Okay, can you
Yeah.
talk about that story?
Yeah. This is an interesting story. The Copernicus story is interesting too. If we have time, maybe we can go to there. But for Galileo, okay, so Galileo is convicted of being suspect of heresy, 1633. If he was convicted of formal heresy, then he would have been executed or excommunicated or both, who knows? But they thought he was just suspect of it because they didn't really know whether he believed it or not, whether he really believed that the Earth went around the sun. They just weren't sure. But if you're going to convict somebody of heresy and execute them or excommunicate, you better be sure. Okay. So since there was some doubt, and the doubt was caused by the fact of the book that he wrote, the Dialogo, because he made it into a play, where three characters are talking back and forth, and it's not concrete, it's not real, it's just made up in somebody's head. All right, so how can you convict somebody of really believing it when they just write a play about it? It's hypothetical as far as they're concerned. So
right, it's
anyway.
like, does C.S. Lewis actually think Narnia is a place?
Well, I don't know about that. He may.
he may.
Anyway, so the Galileo is having a very introspective moment in his remaining years. He dies in 1642, so that's only 9 years from 1633 when he went on trial. And by 1639, he's having some real spiritual movements in his soul. And before this, Galileo was a member of an underground movement to undermine the Catholic Church. Okay. He signed his name on the dotted line. He was into it. Okay. And this was one of the things he was using to undermine the Catholic Church, this whole cosmology thing. And anyway, by 1639, he has a very intense spiritual experience where he gives his life totally over to God and now becomes a true Catholic. Okay. And then he dies 3 years later. One of the evidences of this is that a friend of his named Rinuccini came to him in 1639 after he had this experience, the spiritual experience, and said that I have an astronomer, Giovanni Barioni, who has discovered stellar parallax. And they all believe that if you had evidence of stellar parallax, you could show that the Earth was moving around the sun. Now, that, of course, we know is false today, but that's what they believed back then. Galileo reacts in a totally negative way to his best friend Rinuccini, and writes this letter and says, there's no way that this could prove that the Earth goes around the sun. God can make the universe any way he wants. And so who are we to limit God? And he's going on and on and on for 3 pages, theological arguments, biblical arguments, and signs his name at the end, sends it to Rinuccini and said, and with the idea, please give this to so-and-so because I want people to know where I stand. And Rinuccini, who's very upset, of course, because he did all the trouble of getting Barioni to bring this stellar parallax evidence, is so upset that he erases Galileo's name off the letter and then stuffs it away in his bureau drawer, and nobody ever sees it again. Until 1909, when the letter is discovered.
Wow.
And they see that Galileo's name, because you can't write something without making an imprint on the paper.
Right.
So you might erase the black, but the impression is still there. And they see Galileo's name there, right?
Amazing.
So
that's amazing.
Yeah. And we didn't get this information for 300 years after. Okay?
Yeah.
There it is, lying somewhere, and nobody's letting it out. Yeah. And the only time that it was publicized was 1968.
Wow.
Yeah.
They sat on that for almost 60 years.
Yeah.
Wow. That is such a cool and interesting story, and it just reminds us there's a lot in history that gets lost, but when God wants us to rediscover it, we rediscover it. So
Yeah,
that's cool.
God is going to have the last laugh.
Amen to that.
I mean,
Hey, Dale, do you have anything else, or do you want to look at some of the audience questions?
I did have a follow-up way back to the question on the Bible. Was that going back too far?
No,
yeah,
do it.
basically, it fits in because we're talking about Galileo, right? So I was going to ask you, look, the same thing that Galileo said in terms of biblical interpretation. Many Christian interpreters today admit that, okay, it's using phenomenological language, right? From the perspective of the earth, the sun stood still. And ancient Hebrews did do that. So in Genesis, we can detect a different perspective, like I think verses 1 to 2, or from God's universal perspective, then it drops to the perspective of the earth. Why would you reject, take a literal interpretation versus just using phenomenological language from the perspective of us here on the earth?
Well, we would agree with those as heliocentrists who want to interpret phenomenologically passages like the sun rose in the east or the sun set in the west. We take those phenomenologically just like the heliocentrist does.
Okay.
We see the sun rise and we say it rises. Okay. And then that's the furthest we go. So our language and understanding in context is flexible enough that both sides can use phenomenological language and know what we're talking about, right? All right. So the next question is, when you want to go beyond the colloquial, beyond the common everyday speech, and you want to find out, okay, what is it that causes the sun to appear to rise? Is it the earth rotating, or is it the sun actually moving? Okay. Now that's a whole separate issue, because now you're getting into the scientific arena and you're moving away from the colloquial common everyday language arena. And now it's going to take a lot more work to figure out what the answer is. Okay. So if we're posed with a scientific question of what actually causes a sunset, the earth rotating or the sun moving, what does scripture have to say, which is our authority? Well, sometimes she uses colloquial language. Yeah, many times. But a lot of times she doesn't. Okay. And in those instances where she doesn't, like Joshua 10, when God adds the moon into the picture to clarify the scientific result or the scientific perspective that should be used to look at this whole thing, well, that's a horse of a different color. See, now we don't have phenomenological language necessarily. Now we have the possibility where indeed the sun may have been stopped in the sky because the moon was stopped in the sky. And we know the scientific contradiction that would occur if we say that both were caused by a rotating earth. Can't say that scientifically. Okay. So now we're in a scientific battle on that one passage, whereas the other passages about the sun rising in the east, they're not going to bother anybody.
Gotcha. Awesome. All right, cool. Yeah, Dane, if you want to move on to audience questions, I know we got 5 starred ones here.
So 3 of these 5 are coming from somebody who told us they were in the flat earth community. And I'm sure you get this all the time, Dr. Sungenis. And so you're probably used to this, but basically, why does Dr. Sungenis stop at geocentrism and not embrace what he's calling the biblical model of the firmament and the flat earth? And on top of that, he's asking, didn't the church believe in a flat earth as well as the firmament above? So I guess we can lump this into basically the question of why geocentrism, but with a globe earth? Why not geocentrism with a flat earth? So I'll let you respond to that.
All right. So let me deal with the second question first. The church never, ever endorsed a flat earth. The only one who came up with the developed theory of a flat earth was Cosmos in the 6th century. And he was a world traveler and made maps of the flat earth and all, but he was the only one. Okay. You have in the fathers of the church, you have people like Lactantius, who was fighting against the idea of the antipodes. And that is that if the Earth was flat, if the Earth was spherical, and a man at the North Pole was standing upright, a man at the South Pole would have to be standing downward. Okay, and he didn't like that idea. That was the antipode idea. And so he was favorable to a flat Earth, because if a man's standing on a flat Earth, he can't go under the flat Earth and stand, right? He can only stand on the flat Earth. So you don't have any antipodal problem. Okay, so that was his quirk. There was a couple of others who were questioning the issue, like Chrysostom would question the issue of the firmament. And he said, what is the firmament? Why would he have that question if it was so easy to understand? Mm-hmm. Because the biblical definition of the firmament is not as easy as the flat earthers are trying to tell us, you see. One of the first things we see is that the firmament is a solid thing in the first chapters of Genesis 1. And then we find out that it's some ethereal thing in chapter 1, verse 14 to 19, when the celestial bodies are put into the firmament. Well, how can that be if it's a solid thing? Mm-hmm. So apparently there's a change from solid to ethereal, and we've got to figure out what happened. Okay. And that's a whole study in itself.
Right.
So the flat earthers are trying to make this firmament as if it has to have one mold. That is the first verses of Genesis 1, and it ain't going to fit the rest of the chapter. So that's why I'm against this idea. They think they're being biblical, and they are halfway maybe, but not all way, because the Bible has a lot more to say about the firmament than just this sort of solid dome structure.
Awesome. Thank you for that. And if people are interested in hearing Dr. Sungenis delve into those matters a lot more, he did debate the late Rob Skiba, and that can be found on YouTube, I believe. But do you know where that debate can be found? Is it on YouTube?
I don't know. I haven't seen it in a while. But okay. I also have the book, Flat Earth, Flat Wrong.
Okay.
That's available on robertsongenis.org.
Cool. If you're interested, Robert, I know it's been a couple of years, so you may not be interested in that, but I might be able to bring on David Weiss if he's still willing. Would you want to do a debate on the flat Earth, or you're kind of?
I've done so many debates with flat earthers, and I just got tired of them after a while. Yeah. So I've moved on to other subjects. Yeah. I just don't want to have my time consumed by something that I really am not interested in debating anymore.
Well, and I'll tell you something that I think is unfortunate. Flat earthers tying themselves to geocentrism can be a bit misleading to the outside world, right? Because they're going to just lump you and the rest in with the flat earth. And it's important to remind people you can be geocentric without being a proponent of the flat earth. So Dr. Sungenis would be an example of that. And sometimes I think
it's uncanny that when we came out with the principle in 2014, that's when we regenerated life into the flat earth movement, because then they have started filling the internet with all kinds of flat earth stuff.
Interesting. Yeah. So it's like, I think it's important to maintain the distance, because, we want to be talking about the hard and fast science of it all, whereas sometimes the flat earth can take you in really weird and wonky directions. But I also want to say, as kind of an olive branch and to be gracious, a lot of flat earthers have great zeal for God and for his glory. So like Rob Skiba was a very zealous man for Christ. And so, I can still find a lot of brotherly love with that community, even if I think they're, as you put it, flat wrong. So another question, and this is kind of one of those leading questions. It's the same guy, Stephen Morrison, who told us he was a flat earther, but he asks, why do you think NASA has lied about the Earth? So your answer may be, I don't think they've lied, but what would you say if someone says, hey, why is NASA why are they lying so much?
Well, I would, to be fair to both sides, I would say, yeah, NASA lies. Okay. But I would also say on the other side that the flat earthers will take that to the exponential degree when they shouldn't. Okay. Now, like, for example, when the flat earthers accused NASA of making up pictures of a spherical Earth, and they use the satellites, and NASA uses satellites to do it, and I know how they do it. They send a satellite about 500 miles, and they make it circle around the Earth and continually take pictures. But when you do that, what do you get? You get peels. You get peels that don't cover all the surface of the Earth. So what you have to do is you have to fill in those spots where the peels don't cover, and you have to inject something in there to make it a complete picture. So a flat earther sees that and says, see, they lied. You can see all these circular clouds over here, and then you see them down here. Yeah, well, because you used the same picture to fill in the gap. That's all it is. It doesn't mean they didn't have the peels originally that they could mold together. Okay.
Yeah.
And then they'll end up saying, well, then the satellites don't exist. That's all just heresy and lies by NASA. And as a matter of fact, speaking of Rob Skiba, before he died, I got him to admit, I said, Rob, come on. Do you believe satellites exist or not? He goes, yeah, I believe they exist.
Yeah.
I said, okay, so doesn't that put a gaping hole into your whole theory about NASA and the flat Earth? And we didn't get that far.
Yeah. He probably thinks they're on a balloon or something. But
what's that?
He probably thinks they're on a big balloon, you know?
Oh, yeah, maybe.
But
at any rate, so there is a picture of the Earth taken from what looks like the moon. And the flat earthers were smart enough to go in there and examine that photo. And when they did, they found that somebody pasted a picture of an Earth on a picture and made it look like it was coming from the moon. And how can you tell? Because the Earth isn't circular, it's in a square. And then they put the Earth in the square, right? So yeah, obviously someone doctored that photo. But you don't take that to the nth degree and say, well, that means the whole thing, NASA always lies about things. There's no satellites, this, that, and the other thing. Now, you might be able to make an argument that they never went to the moon with that. Yeah, I'll grant you that. And that's one of the lies that NASA may be saying. Okay. But it doesn't make the Earth into a flat Earth, because NASA lies sometimes. Mm-hmm. And that's the problem I find with them.
Yeah. That's a really good point. Like, NASA lies, therefore space is fake, is a lot like saying, the White House lies, therefore the United States of America is fake. Like, it's like, it doesn't follow. Just because you lie about one thing doesn't necessarily mean you lie about absolutely everything. And anyway,
I mean, I don't know if you've heard this, but the devil comes with 90% truth and 10% lie.
Yeah.
You see? Yeah.
It's true. No, there's a lot of truth in that. I mean, he quotes Psalm 91, which is a great psalm. He's just twisted it, right? So, okay. The last few questions we have, Jamie Russell put them in, and we love you, Jamie. These aren't exactly on the topic, but, we'll go ahead and show them anyway. Well, one of them actually is. So, on your model, Dr. Sungenis, of geocentrism, what are the implications on what a day is? I guess it would be the same amount of time. It's just that the sun is going around us, right?
Yeah. Both the heliocentric model and the geocentric model have to deal with the fact that the stars travel faster than the sun does. If you're looking at it from the perspective of the sun and stars rotating around the Earth, and if you don't deal with that, then you have to have a fix for the fact that the Earth rotates in 23 hours, 56 minutes, and 4.9 seconds, but the sun goes from midnight to noon in 24 hours. Okay. Now, there's a 3-minute, 56-second difference between that. And so each model has to take that into account. The heliocentrics do it by saying that the sun does this 365.25 times a year, and that's how we get our calendar. Okay. The geocentrists basically do the same thing. What they say is that the stars revolve around the Earth in 23 hours, 56 minutes, 4.09 seconds. And the sun revolves in 24 hours. And so there's a difference there. And if you add up that difference, then the sun is going to move against the stars in a retrograde motion about 1 degree per day. And it's going to go through the zodiac in what? 365.25 days. Okay. So each of us has to deal with that fact, and we deal with it in different ways.
Awesome. All right. Well, I think that's probably good. Jamie did also ask this question: did God invent a week or adopt it? Yeah, Jamie's our Seventh Day Adventist friend, so I would say God invented the week. You know, that's what the Bible seems to be teaching. But you know, it's just kind of an interesting question, I guess.
You want me to tackle that?
Yeah, go for it.
Okay, so what God first did is invent the day. Okay, so on day one, it says at the end of the verse 3, it says, and there was evening and morning one day. So that definition is first. And then the second day, it says the same thing. And there was evening and morning a second day. Third day, same thing. Fourth day, same thing. Fifth day, same thing. Sixth day, same thing. So there's 6/7 of the week. And then you come to the end, the seventh day, and the Bible doesn't go to the eighth day. It only stops at 7. So we know now the week has been established. But that can only be established after you establish that the day is an evening and a morning.
Right. Cool. Well, this has been really fun, Dr. Sungenis. Thank you so much for your time and your insights. And I'm actually looking forward to going back and listening to this video again, because we packed a whole lot into 2 hours here. Dale, do you have anything you want to say before we close out here?
Just it was interesting listening. There were a few things I learned and didn't know about. Obviously, I still need to do a lot more research and stuff before I would claim to have a warranted opinion either way and stuff. But it was just interesting. I mean, especially on the scientific aspect, that's where I was most interested in stuff like that, and trying to figure out, because I myself, with relativity theory, I take Dr. William Lane Craig, I take a neo-Lorentzian view and stuff myself. So some of what Robert was saying made sense there on that front and stuff. So yeah, I think it's another thing that we clearly agree on that I liked is that, look, that, people think, oh, the science of cosmology is just like an absolute conclusive science and everything they say and stuff like that. No, there's a lot of philosophy that's in there, and a lot of underdetermined, I guess, conclusions and stuff like that. So you have to evaluate the reasoning, why people are saying or concluding one thing versus another interpretation and stuff like that, and look at the different models and assess which one's the best explanation and stuff like that. So yeah, that's the one thing I took away.
Thank you, Dale.
No worries.
Dr. Sungenis, if people are interested in pursuing this topic into more detail, can they go to your website and find your books, or where would you direct people for that?
Yeah, they would go to www.journeytothecenteroftheuniverse.org.
Cool.
And they'll find all the books and DVDs and the principle, everything is there.
Awesome. So yeah, anyone in the audience that wants to keep studying this, if this is new to you, check out some of the resources on that website. And it's just such an interesting conversation. And I do love the apologetic force of we're the center of the universe. We're unique. God placed us here as a special, the most special part of creation. And I think that there's great apologetic weight with that. And so it excites me to know that that's not just some wishful thinking, but there's actually some science and good reasons to hold to that as well. So, all righty. Well, we're going to wrap up, and God bless you all. Remember to like our videos and share them, and subscribe to the channel if you have not done so already. Till the next time we meet, stay like Christ and be showing grace and love and peace to the world. All right. Bye, everybody.
Take care.